Hi, my name is Mike Blankenship. Today we are going to demonstrate the use of the globe valve seat repair kits. This tooling was designed by Puget Sound Naval Shipyard. There are separate kits for high pressure valves and kits for low pressure valves. This training and tooling is based on 3 NAVSEA technical manuals: 0989-150-0000 titled Standard Naval Nuclear Valves and Auxiliary Equipment. Chapter 6 of this manual applies to the high pressure valves. The 0948 LP 012-5000 titled Standard Navy Valves. Chapter 4.1 of this manual covers the low pressure valves. These valves are detailed on NAVSEA drawing 803-2177525 and 0989-059-6000 titled Special Tools and Procedures for Naval Nuclear Valves and Auxiliary Equipment. Section 2-3-8 of this manual discusses in detail the procedures and use of this tooling. These kits and spare parts are available through the Naval Supply System and from Puget Sound Naval Shipyard Supply System. The kits are designed to restore the seating surface to plan requirements without measuring seat angles, and to restore seats faster than conventional hand lapping methods. This tooling is provided to either lap or cut the seat. I will demonstrate the use of this tooling on both primary high pressure and secondary low pressure valves. Make sure you use the correct kit for the valves being worked. This is a 1-inch primary high pressure valve with a 90-degree seat. And this is a 1-inch secondary low pressure valve with 30-degree seat. Laid out on the table is a complete set of tooling found in a 1-inch low-pressure kit. Be sure you have inspected all the tools for completeness as shown on the material list. This is the A-port cleanliness plug and its insertion tool, B-port cleanliness plug and its insertion tool, the cleaning stick, the guide bushing, the FME barrier, which goes on the end of the guide bushing, a set of 6 guide washers, which is used to help center the guide bushing, 4 Allen nuts and an Allen wrench to secure the guide bushing, a frame assembly, a drive adapter, which replaces the hand wheel in the event you have space restrictions, a carbide seat cutter, a feed stop assembly, which is composed of the feed stop clamp and the feed stop collar, a burlap, a lap handle which is used to drive the laps, 3 seat laps, 180, 300, and 600 diamond grit, a bore lap, a blue check tool, and an instructional videotape. Now that we have checked that all the tools are in the kit, we can go ahead and begin the repair on the low pressure valve. Right after the bonnet has been removed, we need to install both the A-port and B-port cleanliness plugs. If not already done, clean the plugs to meet system cleanliness requirements. Cleaning of the blue polyurethane plug should be done with soap and water per the applicable cleanliness controls. Be sure to check your plug for damage or tears on the sealing surfaces prior to use. For straight valves, you would use a bullet-style cleanliness plug like this one in the A-port, and a fluted style in the B-port. For angle valves, you would use a fluted style in both A and B ports. For straight valves, thread the insertion tool into the non-controlled bullet-style plug until it bottoms out. Then back it out a little way so it's easily unthreaded. Push the plug into the A port until it bottoms in the port, and then thread the insertion tool. Now we need to install the B-port cleanliness plug. Be sure to check the flutes and lanyard for damage. Ensure that the last flute is completely installed in the port. Now I'll remove the insertion tool from the lanyard. Be sure to control the lanyard per the system cleanliness requirements. Prior to starting the repair, inspect the seat. Based on the extent of damage, you can either cut and lap or just lap the seat. If the defects are shallow, then lapping is all that is necessary. Larger defects, seat misalignment, out of roundness, or improper seat angle will require both cutting and lapping. When in doubt, cut and lap. In this particular valve, there are a couple of obvious defects that we have put in the seat. This will require the use of the seat cutter. Now we are ready to remove the gasket. I have two tools that can be used to accomplish this. The first tool is a pointed O-ring removal tool. The second tool is a brass hook. These tools are detailed in Chapter 1 of NAVSEA Technical Manual 0989-150-0000. The tool you use should not damage the gasket sealing surface of the valve. I'm going to use the pointed tool and carefully remove the gasket. Next, we want to vacuum and clean the surface of any remaining gasket material. Wipe down the area around the bonnet studs with a lint-free cloth and alcohol and water solution. Be sure while you're wiping down the valve not to push the B-port plug further into the B-port. Inspect the phonographic finish and the counterbore for excessive rust and raised metal or an out-of-round condition which would prevent the guide washer from being installed in the valve. The counterbore on low-pressure valves is critical for the proper alignment of the guide bushing. Be sure to refer to the two sections in Technical Manual 0948 LP 012 5000, which apply to the counterbore. They are located in Chapters 1 and 4. These sections provide detailed inspection and repair requirements of the gasket sealing surface. If repairs are required, they should be done prior to accomplishing the seat repair. PSNS has a counterbore refurbishment kit for repairing this surface. As you can see, this counterbore is in good condition, so repair is not required. The low-pressure kit is provided with 6 guide washers. Their outside diameters vary in increments of 0.02 of an inch. These sizes cover a range of counterbore diameters that will be found in a valve. Each guide washer has a different outside diameter marked on it. I'm going to start with the smallest guide washer and find one that best fits the counterbore. I'm going to try the next size up and see how it fits. It's too big. Be sure you don't force this. So we'll go back to the size down where we were just at. It should fit snug. Inspect the guide bushing for defects before installing it. Check the top surface for raised metal or burrs which might interfere with the feed stop assembly. Also, check the guide surface for any raised metal or burrs which might interfere with the guide washer. Check the fit with a lap. The fit should be tight with minimal clearance. The FME barrier is a flexible polyurethane seal which is mounted on the end of the guide bushing. Inspect for defects or tears, which will affect the seal with the bridge wall of the valve. Prior to installing the guide bushing and FME barrier, be sure to meet system cleanliness requirements. The guide bushing won't fit into the valve with the B-port plug installed, so we'll remove it. I'm going to vacuum around the flutes of the plug and inside the valve before I remove it. Pull the B-port plug into a damp, lint-free cloth. This will keep the plug in control during removal. Now you can install the guide bushing. Tighten the Allen nuts on the bonnet studs, alternating from side to side. Tighten them in small increments until the guide bushing is bottomed out. Try to keep the guide bushing parallel with the top of the valve. After you've tightened them, make sure the guide bushing is tight against the top of the valve. There should be no gap between the valve body and the guide bushing. Next, we need to install the frame onto the guide bushing and tighten the retaining screws. Earlier, we showed you the adapter for replacing the hand wheel when space limitations prevent the use of the hand wheel. Here's a frame assembly with the adapter installed. To maintain the best alignment of the cutters, laps, and blue check, it is recommended that the guide bushing remain in the valve until all repairs to the seat are complete. At this point, I want to discuss the installation of the high-pressure guide bushing. This is the main difference between the high-pressure and low-pressure kits. Inspect the high-pressure guide bushing as we did on the low-pressure guide bushing. Be sure to clean the guide bushing to meet system cleanliness requirements. Remove excess graphite from the threads. Excess graphite on the threads can cause galling. Lubricate the threads and the end of the guide bushing with graphite and isopropanol. The guide bushing I have here has already been lubricated. Thread the guide bushing into the valve and tighten to achieve metal-to-metal contact with the bridge wall. After the guide bushing has been installed, we'll need to install the A-port cleanliness plug. Be sure to inspect the plug for tears or damage. Push the plug down firmly until it seats against the bottom of the port. Now I want to check for proper contact of the guide bushing with the bridge wall of the valve. I'm going to remove the guide bushing and inspect the end of it. The graphite should show some contact by being removed as shown here. If no contact has been made with the bridge wall, then the guide bushing is probably binding in the counterbore due to counterbore weld shrinkage. Refer to NAVSE Tech Manual 0989-059-6000 for additional guidance on this problem. Now I'm going to reinstall the guide bushing. Attach the frame and tighten the retaining screws. Install a blue check tool. Now back off on the guide bushing slightly so that it's no longer in contact with the bridge wall of the valve. While firmly pushing down on the blue check tool, tighten the guide bushing. This will help center it. Be sure it's tight enough to prevent accidental loosening during valve seat repairs. Installation of the high-pressure guide bushing is the main difference between the low-pressure and high-pressure kits. The remaining steps are identical for both low-pressure and high-pressure kits. These steps will be demonstrated only on the low-pressure kit. Now that the guide bushings are installed, let's move on to cutting the seat. Visually inspect the seat cutter for sharpness and any visual defects. Check the outside diameter for any burrs or raised metal. Carefully place the cutter into the guide bushing, taking care not to drop it. If the cutter free falls against the seat, it will probably chip the carbide and scar the seat. Hold the cutter firmly as you slide it down, making gentle contact with the seat. Now we are ready to install the feed stop assembly. It provides positive control of the cutting depth. Make sure the feed stop assembly rotates freely with no hang-ups on the threads. To set the proper cutting depth, run the feed stop clamp down until it bottoms out on the feed stop collar. Unthread the feed stop clamp one full turn. Continue rotating until the split in the clamp lines up with the 0 mark on the collar. Place the assembly onto the cutter with the feed stop collar against the guide bushing. Ensure the feed stop assembly is seated on the guide bushing. While holding down on the feed assembly and the cutter, tighten the upper screw on the feed stop clamp. Use a 1.5 thousandths feeler gauge to check that the feed assembly is bottomed against the guide bushing. Since the valve has a 30-degree seat, I will rotate the feed stop collar counterclockwise 2 graduations. This will set the cutter travel at 4 thousandths of an inch. For a 60 or 90-degree valve, we would adjust the feed stop assembly in 2 thousandths increments. Actual metal removal will be less than what is shown by the feed stop clamp due to the angle of the seat. Less metal is removed for each increment on a 30-degree valve than will be removed on a 90-degree valve. This table shows how much material is actually being removed from the seat for every 2 thousandths inch of cutter travel. The next step is to tighten the feed stop collar. Swivel the frame assembly over the seat cutter and engage the drive shaft with the cutter. Rotate the hand wheel and feed shaft to align the drive shaft with a square on the seat cutter. Continue rotating the feed shaft clockwise until the drive shaft bottoms out on the seat cutter. You are now ready to begin cutting. Rotate the hand wheel in the clockwise direction only. Turning the cutter counterclockwise could break the carbide edges. Begin feeding the cutter by rotating the feed shaft clockwise. Rotate the hand wheel in large arcs. And continue feeding the cutter until the feed stop assembly is bottomed out on the bushing. Now let's check to see if the feed stop clamp is bottomed out on the guide bushing. We'll do this by attempting to insert a 1.5 thousandths feeder gauge between the stop collar and the guide bushing. Okay, the feed stop collar has made contact with the guide bushing. To finish the cut, continue rotating the handwheel clockwise. Then turn the feed shaft in reverse. This eliminates any marks left on the seat by the cutter. Also, unloading the cutter while it is rotating improves the finish on the seat. Now let's move the frame assembly out of the way so we can remove the cutter. Carefully pull the cutter into a lint-free cloth. The cloth will contain the chips and debris which may be stuck on the end of the cutter. Wipe off the cutter and inspect for chip carbide. If the cutter is chipped, inspect the seat. If the surface finish of the seat is rough, it may require the use of the 180 grit lap or recutting with an undamaged cutter. Now let's clean out the chips so we can inspect the seat. Vacuuming will not remove all foreign materials. After vacuuming, wipe down the seat with a lint-free cloth. Final cleaning will produce a seat area that is free of foreign material and is ready for inspection. Let's take a look at the seat and see if we've removed the defects. As you can see, we still have defects in the seat. We need to continue cutting, so I'm going to adjust the feed stop assembly an additional 4 thousandths of an inch. Loosen the stop collar and rotate it 4 thousandths of an inch so the split lines up with the 8 thousandths mark. If this valve had a 60 or 90 degree seat, we would have adjusted the collar only 2 thousandths of an inch. Okay, let's go ahead and continue cutting. What you're seeing is a view from underneath the cutter. Obviously, you'll never see this when you're repairing a valve. Notice that you have a lot more chips than you would see with conventional lapping methods. We have fed the cutter a total of 24 thousandths of an inch. Reviewing the chart shown earlier for a 30 degree valve, we have determined that we actually removed 6 2/10 thousandths from the seat. Looking at the seat again, we can see that the defects have been removed. Lapping is a process that removes minor imperfections and gives you a surface finish of 16 microinches or better. After cutting the seat with the cutter, burrs may form on the top and bottom edges of the seat. The burrs on our valve are difficult to see on camera. Here's an example of a burr that was formed on a 1/2 inch low-pressure valve. Incidentally, this valve was rejected due to excessive pitting in the seat. The bridge wall burr will need to be removed before proceeding with the seat laps. If you were to use the burr lap after using the seat laps, a slight burr might be left on the edge of the seat. We will use a burr lap to remove the burr. This is a 180 grit burr lap with a 150 degree end angle. Now let's insert the burr lap, being careful not to drop it. The lap handle is provided for use with all the laps. It mounts on the undercut area just below the diamond grit. Typically, it only takes a few turns to remove the burr on the upper part of the seat. After burlapping, clean and inspect the seat. Now we're ready to lap the seat. As you can see from the chart, a 180 grit lap will give you a 63 micro-inch finish. A 300 grit lap will give you a 32 micro-inch finish, and a 600 grit lap will give you a 16 micro-inch finish. If the seat cutter left chatter marks, lapping is the only way to remove them. If your valve has chatter marks, start with a 180 grit seat lap. Since chatter marks are not present on our valve, we'll start lapping with a 300 grit lap. I'm going to apply graphite and isopropanol to the seat so I can easily see any low spots or misalignment after lapping. Since we used the seat cutter prior to lapping, low spots and misalignment should be minimal. Here you can see the seat is covered with graphite. Carefully insert the 300 grit lap into the guide bushing. Install the lap handle. Now I'm going to rotate the lap 2 to 3 turns or until the lap loads up. You can tell when the lap is loading up by the way it feels or sounds. If you feel a rolling sensation or hear a squeaking sound, then the lap should be cleaned. Notice I rotated the lap in the clockwise direction. The next time I use this end of the lap, I will rotate it in the opposite direction. Doing this will give you the best life and cutting performance for your laps. Now let's remove the lap and inspect the end of it. This lap is completely loaded up from removed material. Once the lap has this much material built up on it, it must be cleaned. No amount of force will make it cut. Clean the lap with a lint-free cloth and alcohol solution. It must be cleaned after each use. Now I'm going to inspect the seat for finish and presence of graphite. We still have an area on the seat that the lap is not touching, so we need to continue lapping with a 300 grit lap. Now I'm going to vacuum and clean the seat. Keeping the seat clean when you are lapping will allow the lap to cut faster. We'll switch ends and continue lapping. Switching ends each time will give you the best finish and lapping speed. Once you have achieved a 32 micro-inch finish and all low spots have been removed, then we will continue lapping with a 600 grit lap. Install a 600 grit lap and repeat the process as we did with a 300 grit lap. The 600 grit lap will load up faster than 300 grit lap. One full turn may be enough to load the lap. Again, we need to clean the lap and seat prior to inspection. Now we'll inspect the seat for a 16 micro-inch finish. After about 10 minutes of lapping with a 600 grit lap, you can see we've achieved better than a 16 micro-inch finish. Now we are ready to lap the bore. The bore lap has a 10-degree angle. This is a steeper angle than either the burr lap or the seat laps. This lap is used to remove any burr that may have formed on the edge between the seat and the bore. There will typically be more of a burr created in the bore on a 90-degree seat than on 30 and 60-degree seats. The bore lap removes material quickly. It should be used with light pressure to minimize material removal. Turn the bore lap 1/2 to 1 1/2 turns. This will typically give you a 1/32 to 1/16 inch wide band of material on the end of the lap. This should be enough to remove the burr. Now I need to clean the lap and seat for a blue check. We'll do a blue check using the blue check tool. The disc angle is the smallest of the two angles inscribed on the tool. It is used to perform the blue check. The larger of the two angles corresponds to the seat angle. It can be used for seat angle and low spot checks. This is a diagnostic tool for resolving unsapped blue checks. Accomplish the blue check by applying graphite and isopropanol to the disc angle end, which I have already done. Insert the blue check tool and apply a firm pressure. A slight rotation, not to exceed 5 degrees, should be used. Inspect the blue check tool for a narrow, continuous circle of uniform width. If the blue check is satisfactory, then the valve is ready to be reassembled and final blue checked. If the blue check is not satisfactory, then additional seat repair is required. See NAVSEA Technical Manual 0989-059-6000 for details on blue check evaluation and troubleshooting. If you're working with a 1/2 inch low pressure valve, then there's one more tool I need to show you. The extractor tool is used to remove the guide washers since they are difficult to remove with your fingers. Now let's go over some of the important points. First, be sure to use the correct kit for the valve being repaired. Next, inspect all components of the kit for damage before use. Be sure to install cleanliness plugs correctly and carefully. Remove only the minimum amount of material necessary to produce the required surface finish and acceptable blue check. Frequently clean the valve internals and the laps to remove material generated during machining and lapping. It is particularly important that the valve internals be free of all chips before removing the cleanliness plugs and the guide bushing. By following Section 2-3-8 of Technical Manual 0989-059-6000, a properly trained worker using tools in these kits can refurbish a valve seat in a relatively short period of time.